So Wednesday and Thursday, we have been focusing on making our plans for our experiments with the yeast to study population dynamics. I'm just going to quickly make this little video to talk about the planning process, but there's no assignment to go with it or anything like that. If you are still absent while we're doing the investigations, then you'll actually just follow like whatever I do in the video. And that's how you'll carry out the experiment. You won't actually do it in person. So, in any good scientific experiment, there are what we call variables, and there are three main types. Um, the high school teachers probably want you to know the names of these variables. They each have a name. If I tell you the name, it's just going to confuse you and you're going to forget them. So, the things that you need to remember are that there are three components of any investigation. There is one thing that you change, only one. There are all the other things that you keep the same. And then later on, you find out the effect. So, what is the response to this change that you made? And so, we talked in class a lot about how anytime you do an experiment, you don't want to change too many things because whatever that response is, you won't be able to tell what exactly caused it. Um, for example, we were talking today about how if you wanted to find out how to make your phone charge faster, and you changed a couple of different things. You turned your phone off while it was charging. You also got a new phone charger, and you put it at a different outlet in your household. Now your phone charged twice as fast, but which one of those things caused your phone to charge faster? It's really like a guess. But if you wanted to make your phone charge faster, or see if it would charge faster, and you kept it in the same outlet with the same charger, and then you just turned your phone off, then if it charged faster, you would know it was because the phone was off. And if it didn't charge faster, then you know that turning your phone off did not help that situation. And so then you might choose to test it out later on with a different charger and then a different day with a different outlet. So you have to know what you're changing to know how it's responding to that thing. Okay, so in our yeast experiments, we will be doing three trials, and each one of these tables, we made these in our labs, our science journals, our science notebooks. Each trial has one of these tables. The first thing is the amount of water. Now, everybody is going to be keeping the 15 milliliters of water. We are not going to be changing that one just because it changes how it looks under the microscope. The other thing you're not going to change is the amount of yeast. Everyone will be working with about 2 grams of yeast per trial. So that's about a quarter of a packet of yeast, a little packet. So the starting temperature of the water, however, you can change. You could make it regular room temperature water, or you could make it really hot water when you put it in, or you could make it really cold water, or we could do like a medium heat, like just warm to the touch but not boiling, things like that. So you could change that, or you could change the type of sugar. So I have a ton of different types of sugars. I have the regular sugar you're used to, powdered sugar. I have what's called sugar in the raw, which is kind of like almost like sugar sprinkles. Okay, so it's like a lot bigger. I also have three types of sugar replacements. So I have aspartame, which is the fake sugar that they put into Diet Coke and Diet sodas. Um, I have stevia and I have Truvia. So those are both sugar replacements. And so you could test that out. You could change those around. Or you could just go with regular sugar and try different amounts of sugar. You could try one that doesn't have any sugar. You could have one that has exactly the 1 gram, or you could have one that has twice that much, or whatever. Okay. You could manipulate the light, the amount of light that whatever your thing gets, or your trials get. So you could put it in the windowsill if you wanted it to have a lot of light. You could put it in a dark room if you wanted it to have absolutely no light. You could also just put it like on the countertop in my classroom if you wanted it to have like a medium amount of light, or we could find a way to put it like under a lamp that's going to stay on because, you know, the lights turn off at night in the classroom and also the sun goes down. So we could work with all of that stuff. And then the last one is the amount of air. So one group had an idea to adjust the amount of air that the yeast have access to. So what they're going to do is for one trial, they're going to put cling wrap on the top of the container with the yeast in it, so that the only air that the yeast have is the air that's in that cup. For another trial, they're going to put it inside of a Tupperware container. So they'll put the cup in the Tupperware container. It'll have a little bit more air. And then for another one, they're going to put it in just like the room. Okay, so it has like infinite air at that point. So you do not need to worry about doing any of this stuff as an absent person. I just want you to be updated on what we're currently doing with our experiments.